Identifying protected health information and related identifiers is the backbone of the model. Protected health information links a person to health context, like diagnoses, treatments, or billing details tied to a name, account number, or other identifiers. Related identifiers can be direct, such as social security numbers or medical record numbers, or indirect, such as precise date combinations or rare procedure codes that narrow to one person in a small population. Teams should inventory the fields that create that linkage and note how combinations can re-identify individuals even when single fields look harmless. For example, a lab result without a name may still reveal identity when exact test date, clinic location, and device serial appear together. By mapping fields and the risk of linkage, designers understand what pushes data into a higher class and how to structure tables and logs to avoid accidental exposure. Creating simple, memorable classification categories keeps the program usable. 4 levels often work: public, internal, sensitive, and restricted, with restricted reserved for protected health information and similarly high-risk data. The exact names matter less than their clarity and the behavioral rules attached. If people cannot remember the levels or struggle to map real examples, the scheme is too complicated. A practical test is to hand a teammate a sample and ask, which class is this and what does that change about how you handle it? If the answer arrives quickly and consistently, the categories are working. Keep written definitions short and include 1 or 2 grounded examples per level. Over time, refine only when confusion is evident. Frequent renaming erodes trust. Stable, simple categories support reliable training, automation, and auditing without slowing daily work. Labeling rules and repository tagging connect the concept to everyday tools. Files, database tables, message queues, tickets, and analytics dashboards should carry a visible label or metadata tag that states the classification. In document systems, use headers or watermarks. In data platforms, use schema tags, column-level annotations, and access labels that policy engines can read. Avoid manual-only labels that drift as files move. Choose methods that follow the object through syncs, exports, and pipelines. For example, a dataset tagged restricted in the warehouse should export with that tag so the downstream lake or notebook enforces the same expectations. Periodic scans help find unlabeled or mislabeled objects, and owners resolve gaps. When labels travel with the data, humans and systems respond correctly without guesswork, and auditors can see the lineage of protection from source to sink. Handling rules by classification level translate labels into action. For public data, sharing is open and storage is flexible. For internal data, casual sharing narrows to staff and partners under need to know. Sensitive data requires stronger access controls, approved storage, and change tracking. Restricted data, including PHI, adds encrypted storage by default, limited export paths, elevated monitoring, and tight review for copying or transformation. Spell out what is allowed for each class in plain language, where it may be stored, how it may be sent, who may view it, and what extra steps apply before use in testing or analytics. Provide clear, if unsure, do this fallbacks, such as defaulting to the higher class until an owner confirms otherwise. These rules remove hesitation and keep teams from inventing personal interpretations that diverge over time. Access controls tied to classification ensure the right people see the right data at the right time. Role-based and attribute-based models both work when roles reflect real duties and attributes reflect context, like job function, location, and device health. The higher the class, the tighter the checks. Strong authentication, least privilege groups, and periodic reviews of entitlements. Break glass access can exist for emergencies, but it should be time-limited, heavily logged, and reviewed after use. Automated provisioning based on roles prevents ad hoc grants that remain long after a project ends. Pair this with ownership. Requests route to the data owner, not a random approver, and decisions are recorded. With classification in the decision path, access becomes predictable and defensible, shrinking exposure while keeping legitimate work moving. Transmission safeguards for sensitive data focus on keeping content confidential and intact as it moves. Require encrypted channels end-to-end, modern transport encryption for APIs and web sessions, secure tunnels for system-to-system transfers, and approved file transfer platforms rather than ad hoc email attachments.
For very sensitive exchanges, layer additional controls like signed payloads, short-lived pre-signed URLs, or tokenized identifiers that limit the blast radius if a link leaks. Document how consumers authenticate, authorize, and verify integrity before accepting data. For routine user workflows, design defaults that avoid risky paths. For example, nudge staff toward a secure portal rather than downloading and emailing reports. When the path is safe by default and convenient to use, people choose it without being told twice, and policy becomes habit rather than a hurdle.
Storage encryption and key handling keep restricted data resilient at rest. Full disk or volume encryption protects lost devices, while field-level or column encryption can reduce exposure inside multi-tenant systems and analytics platforms. Keys deserve the same care as the data they guard. Generate them in a managed service or hardware-backed module, rotate on a defined cadence, and separate roles so the people who manage storage cannot read keys. Logs should show who accessed keys and when, with alerts on unusual patterns. Avoid burying secrets in code or configuration. Use runtime retrieval through approved libraries. Test recovery with simulated key loss so teams know the path back is reliable. When encryption and key management operate as a routine service, storage choices expand without sacrificing the safety of PHI. Data retention periods and triggers prevent accumulation that silently raises risk. For each data set, define a purpose and the event that starts the clock. A treatment end date, contract expiration, account closure, or regulatory milestone. Match duration to need, then automate deletion or aggregation when the time is up. Reports should show what was due, what ran, and what exceptions remain, with owners accountable for closure. When analytics benefit from history, consider de-identification techniques that reduce risk while preserving trends, and keep linkage keys apart with strict controls. Clarity here helps staff respond confidently to questions like, why is this 5-year-old record still present? A crisp answer, backed by a schedule and logs, turns a potential finding into proof of discipline and care. Secure disposal and sanitization methods close the life cycle with the same rigor used at intake. For physical media, use approved wiping standards or destruction services with certificates that list serial numbers and methods used. For virtual storage, ensure deletion propagates through replicas, snapshots, and backups according to the schedule so remnants do not linger. Application owners should design purge routines that remove associated indexes, caches, and derived datasets that otherwise escape notice. Test disposal end-to-end on non-production copies to verify nothing breaks and nothing reappears. Document the process in concise runbooks so handoffs do not introduce variance. When disposal is predictable and evidenced, the organization earns back capacity, reduces liability, and proves that promises about the end of data life are real. Third-party sharing controls and approvals extend classification discipline to partners. Before any transfer, confirm purpose, minimum necessary fields, security expectations, retention limits, and onward sharing rules. Contracts should reflect those points and reference the technical controls you expect: encryption in transit and at rest, access reviews, logging, and incident notice timelines. Maintain a register of vendors that shows which classes they receive, which systems they integrate with, and the owner responsible for oversight. Start small with datasets and expand only after value is proven and controls are verified. Periodic checks, lightweight but real, look at samples, logs, or attestations to confirm practice matches promise. With this cadence, partner risk stays visible and bounded rather than assumed away. Evidence examples make the program auditable without scrambling. Keep short, current records that show classification definitions, the data registry with owners, sample labels in repositories, access review outputs, encryption configurations, transfer logs, retention reports, and disposal certificates. Screenshots, exports, and ticket links are enough when they clearly show who did what, when, and for which dataset. Organize these materials by control topic so reviewers can navigate quickly, and automate their collection where possible to reduce human error. Treat evidence as a byproduct of normal work rather than a separate project. When questioned, teams can produce a clean trail from label to handling rule to control output, demonstrating that protection is consistent, measured, and repeatable. A consistent, auditable data handling posture emerges when classification informs every step rather than living in a document alone. Owners are known,
Labels travel with data, handling rules guide behavior, and access, transmission, storage, retention, and disposal all align to the declared class. Partners follow the same pattern under written expectations, and evidence accumulates naturally as systems operate. The result is a program that protects individuals, supports care and business workflows without friction, and withstands review because it is simple to explain and easy to verify. By keeping categories few, rules clear, and proof close at hand, teams transform sensitive data from a source of anxiety into a well-managed asset worthy of the trust placed in it.